I'm not going to walk you through the blank slate demo scenario where we'll basically build a model from the ground up to really illustrate that agile and iterative think as you work approach the LavaStorm Analytics engine enables. So in this particular scenario, I'm a business analyst, and my boss just walked over to my desk and asked me to take a look at the recent billing files that we received and compare those to the order management and CRM system extracts that we receive each month. He mentioned a slight concern with the data quality as he was walking away, but told me to kind of work through it and send him the results of the analysis in an Excel spreadsheet. So given these kind of vague instructions, we're now going to walk through the steps to build this sort of analysis within the product. The first step in any sort of analysis is data acquisition. And the main takeaway here is that the product has native capabilities to bring in data from virtually any type of structured data. Additionally, several of the product's interfaces and adapter nodes provide the ability to bring structure to semi-structured and even unstructured data sources through third-party tools or integrations. So whether that data is in CSV format or it's an Excel format or a fixed format or even XML or JSON, there is a pre-built node within the product to handle the quick and seamless data acquisition of those file types. There's also a database query node which provides the ability to interface with a variety of different databases directly. So this single node provides direct access to Oracle, to Teradata, to SQL Server, DB2, MySQL, and even Access. And of course, you can directly connect to multiple databases at the same time by just adding a second database query node onto the canvas. To start with, let's bring in our billing data, which is in CSV format. So I'll drag and drop a CSV file node onto the canvas. And if I open the node editor, we simply need to tell it where that data resides. So I'll navigate to one of our billing files, and we'll go ahead and call this billing data. And now if we press the play button, it's going to execute that node and bring in the data from that underlying CSV file. And just like that, we've completed data acquisition for our billing extract, and we can immediately take a look at the data and start doing something with it. Next, let's bring in data from our CRM system, which is actually in an Excel format. The LavaStorm Analytics engine also has native drag and drop capabilities from Windows Explorer. So we can drag and drop our Excel spreadsheet onto the canvas, and it'll auto wire up or auto configure an Excel file node pointing at that spreadsheet. And here we'll call this CRM data. And just like before, if we press the play button, it's going to execute that node and bring in the data from that underlying spreadsheet. And again, we can start taking a look at the data and doing something with it. So the idea with the LavaStorm Analytics engine is that data acquisition is intended to be straightforward and simple. There's no underlying database with the product, and therefore there's no sort of metadata mapping step required at the beginning. It's simply point, click, and go. Again, the theme here is agility. If you notice earlier, we selected a single CSV file from a directory of other billing files. What if we wanted to bring in all of those files as they represented a broader set of data from our billing system? Well, just like on the CRM data, which is in Excel format, we can also drag and drop directories from Windows Explorer. So if I select our billing data directory here and drag that onto the canvas, it'll auto-configure what's known as a directory list node, and we'll call this billing files. And if we run that node, it's going to bring in all the files that exist within that directory. There's also wildcard matching or mapping capabilities within the directory list. So we can tell it that we only want a subset of files based on that file's type or the file name or even the file date. And now we can wire the output of this directory list into the input of our CSV file node. And if we open up that CSV file node and tell it instead of sourcing from a single file, we're going to source from the input. And in this case, that'll be from the file name field that exists within our input. And then if we rerun that CSV file node, it'll bring in all the data across all 14 files. And so with this slight change, we can now dynamically source the data from this folder in the future. So if tomorrow there are 25 files that exist within our folder, our model operates exactly the same without any sort of tweaking. It simply flows straight through. Next, we'll bring in some data from our order management system, which in this case is an extract we received from IT in a specific delimited format. Again, I could use a directory list node here, but for the sake of time, we're just going to point at a specific file. So I'll select that order management data file, and we'll call this order management data. In this case, we also need to specify the field delimiter and record delimiter as there's a little bit non-standard. So in this case, our fields are separated by a pipe and our records are separated by a line feed. And now if we run this node, we get an error. So something went wrong with the acquisition of this particular data file. We can hover over the node and see the actual error message that it's telling us. So in this case, it's telling us, hey, at record number 8, we received 12 columns, but we only expected 10. So at record 8, we came across some bad data within the file that invalidated the structure of the actual file. So what do we do now? This file could be corrupted, or perhaps there's a series of bad records within the data set. And in most scenarios, this is where we would have to go back to IT and ask for assistance, or God forbid, we might actually dive into the file and try to manually manipulate the data to clean up those bad records. All of the nodes within the product have an I/O tab, which represent the inputs and outputs of that particular node. With the data acquisition nodes, you can actually add a second output. In this case, we'll call it air, although you can name it whatever you like. And if we rerun that node, it's going to suppress all of the bad records to a secondary output. So in this case, 99% of our data is good or in a clean state. And we don't want to have to delay or stop our analysis because of 6 bad records. So not only can we continue forward with our clean data in this case, but we also have clear visibility into the bad records that exist within our file. And we can take a look at those bad records. So if we open up the data viewer, it'll tell us the record number where the failure or the error was encountered, the actual error message, and then the data record that caused the error. So in this case, we could even build some additional rules to clean up those bad records and join it back with the good records, or we could attach those bad records to an email node and send it to the team that manages this particular extract. One of the activities I often do when starting with a fresh set of data is run what's known as a data analyzer node against the data set. The data analyzer node is a powerful node that will essentially profile the data record by record, column by column, and perform an analysis of the full data set to, among other things, understand the data quality of the data that you're dealing with. So here I connected 3 of the data analyzer nodes to our 3 different data sets, and if I run those in parallel, they're going to profile the data and perform that analysis. There are multiple outputs of the data analyzer node, but the one that's of most interest is this middle pin named analysis. So if we look at the analysis pin associated with our CRM data and we double click on it, it'll launch the data viewer to give us some insight into that actual analysis. So in this case, it's telling us here we have 13 columns that exist within our CRM data, and here's some information or details about each one of those columns. If we take create data as an example, the first 2 fields deal with the type of data. So this is simply telling us that our create date within our Excel file in its native format is actually of Unicode type. The second column, discover type, is actually telling us that after going through the full data set, the field was actually discovered to be of date type. So this node does auto type discovery from the data directly and provides you with the details. Additionally, it also converts the data for you based on this discover type all out of the box. The additional columns here provide further insight in the data. So you see things like min and max value, min and max length, and null count. Min and max length give you insight into potential data quality issues. So the min and max length, if we look at account ID here as an example, we can see there's a fairly large variation in the size of our account ID across our full data set. More importantly, we see that there are 113 records with a null account ID within our data set. This immediately raises a red flag in my mind. It tells me that we need to, at a minimum, look at these null records and probably, more likely implement a business rule to deal with them directly. So let's do that. If we take a look at the converted data output, we'll see our full data set has now been converted based on that auto type discovery we discussed earlier. And if we look at create date as an example, we'll see that it's now of date type, which means we can do date and time operations on top of this particular field. We can also look at our account ID, and if we sort our account ID, we'll see some of the null values that were brought to our attention with the data quality checks we discussed a little bit ago. And we can take a look at some of the other data attributes associated with the records that have this null account ID to maybe explain why it's null or further validate that it is a data quality issue. Or maybe in this case, we simply want to segment out these 113 null records because they represent a true data quality issue. We could bring up a filter from our palette and build that within the canvas, or we can actually even build a filter node directly from the data within the data viewer in front of us. So if I select one of these instances of the null value within the account ID, and I go up to edit copy as examine filter or examine split, in this case I'll use an examine split node, and then we go back to the canvas and paste that, we'll see that we've created a filter node, or a split filter node in this case, with the business logic implemented. And if we connect that to our data stream and then run it, it's going to segment out those 113 null records. So just like that, in a very quick and straightforward manner, we were alerted to a potential data quality issue. We took a look at the data to validate that it was a data quality issue, or maybe even help understand why it existed as a data quality issue. And ultimately, we implemented a business rule to separate out these records with only a few clicks and absolutely zero coding. And again, we can take a look at these records separately and validate that our business rule was implemented correctly, or even perform additional data discovery if necessary. The split node is useful in this context because it provides us with full visibility and traceability into the data before and after the business rule. So from here, we can configure a separate flow to deal with these 113 records on their own. Maybe we want to send them off to IT again via an email. Maybe we want to join them to another data source or a source system to get that account ID, or as we'll actually do now, we can ignore them and move on with our clean data set. At this point, we are now ready to bring together these disparate data sources for further analysis, and this is where our correlation category of nodes comes in handy. If you have any sort of experience with databases, you'll see that we have several different join types as individual nodes within the product. We also have fuzzy matching nodes, which allow you to do non-distinct matching between data sets. So these fuzzy matching nodes support 7 different algorithms for fuzzy matching, such as Levenstein distance, SoundX, and various numeric and date and time algorithms. An example I often use is that if you had 2 systems with a customer's first name of Sean, and in one system that Sean was spelled S-E-A-N, and in the other system it was spelled S-H-A-W-N, you could use the fuzzy matching nodes with the SoundX algorithm to deem them a match because phonetically they're the same thing. One of the most commonly used correlation nodes is the crossref or xref node. And this particular node will allow you to take 2 data sets and based on a key or set of keys, provide you with a full picture of both the matches and the non-matches. So in this case, we'll hook it up to our billing data and our CRM data separately. And then if I open up the node editor, we'll need to configure a couple parameters. So the first thing I need to do is tell the node how to actually match these 2 separate data sets. The left input key parameter here represents our billing data. And so within this parameter, we'll select from our input right context menu the billing customer reference field. And then on the other side, our right input key, which is our CRM data, will select another field. In this case, it's going to be the customer reference field that exists within our CRM data. So these 2 field names don't actually need to match. We simply just need to tell the node what fields to use to actually compare for the cross-referencing. And then I'll go ahead and name this reconcile billing to CRM, and then we can actually execute the node to do the cross-reference. And so as a result, we see that we have 3 separate results from the node. We have 9,092 matches that we can see in our middle output pin, and we can also see that we have 131 left orphans and 785 right orphans. So not only do we see the matches, we also get the full picture of what did not match, which in this case is telling us we have 131 customers that exist in our billing system that are not in our CRM system, and probably more importantly, we have 785 customers that are in our CRM system that we're not currently billing for. This same sort of operation in a database would take 3 separate SQL queries. Instead, we did it with a single visual node and only a couple of configurations. So not only is it an easier approach, it's actually more efficient because it only processes the data once. And from here, we can continue on with our analysis. If we take a look at the results of the cross-reference, we're probably most interested in the 785 customers that are not currently being billed. So let's take a look at those customers. Again, the idea here is to work through the analysis the way you logically think about the problem set. So if we take a look at the data, we can start inspecting some of the other data attributes to help understand why these customers are not in our billing system. So maybe in this case, all the customers that are in Aberdeen and in Belfast and in Cambridge, the customers that are in those towns are actually handled by a separate billing system. And we want to implement a business rule to remove those or segment them out because they're actually false discrepancies in this scenario. Again, we can build a business rule directly from the data viewer as we did earlier. I've already selected those 3 separate towns, and if I go up to Edit Copy as Examine Split, and then go back to our canvas and paste the split node, we've again created a business rule directly from the data to further refine our result set here. And if I execute the node, it's going to separate that 785 discrepancies into 2 separate paths. And we can validate that all the customers that are in the first path fall within those 3 different towns, and then we can continue forward with the 754 discrepancies that are actual valid discrepancies. And just like that, we've refined our result sets based on what the data was actually telling us. And we can continue on in this manner. So step-by-step inspection of the data as we discover and implement the business rules from the data. We build this model from left to right the way we logically think about the problem, asking questions and inspecting the data in a very agile and iterative fashion. This is the value of the LavaStorm Analytics Engine from both an implementation and a methodology perspective. One other item to touch on here is documentation, and this shouldn't be confused with help, which is very extensive, but actually documentation at the node level. Every single one of our nodes has a documentation tab where you as a user can capture the business context of the business logic being applied at that particular step. So in this case, we can type in something like, here we are removing customers that are in towns handled by a separate billing system. And then if we go back to our overall model and we hover over that node, we get a tooltip of the nodes captured within that documentation tab. So not only can we logically understand what's happening throughout our model through its native kind of visual flow, we also have the ability to understand why we implemented this specific rule or this specific set of business logic at this step. And from a best practices perspective, this becomes very powerful because it again collapses that implementation model and allows the user to capture documentation as they build and as they configure their models. And more importantly, if we hand this model over to a colleague, he or she can quickly understand what the model is doing, but also understand and access the business context of why these specific rules were implemented. Additionally, we can take this a step further and actually generate a full set of documentation from what was captured through the model as it was configured. So if we go up to Tools and go to Generate Documentation Graph Reports, this will produce an HTML document of all the notes that we captured throughout our models. Now, it's probably not going to read like a novel, but it's a great starting point for any sort of internal or external documentation assets associated with the stream of work. And some of our customers actually use this to generate documentation as a starting point or even a core component of their broader compliance requirements. I mentioned composite nodes earlier in the core concepts demonstration, but the way you actually configure composite nodes within the model is if we selected our billing data acquisition nodes that we configured earlier and click on the Group Selected Nodes button, it'll create a composite of those nodes that we can name billing acquisition. So now we have a single logical container with the details of the billing acquisition inside. And we can drill into this composite node and see those individual detailed nodes. And then, of course, we can drill back out either through the top point here to see our high-level flow. And so composite nodes basically allow you to better visualize or organize your models and create a level of abstraction that represent the logical view of the technical details. We can now take this composite node concept a step further and actually create a reusable library node of our own. So let's take the data analyzer node and the filter to remove the null accounts and group them into a composite that we'll call CRM data cleanse. And now if we select this newly created composite node and go up and hit the convert to library node, it'll convert this composite node into a library node for us. So what does this mean exactly? If we go down to our palette, we'll notice that we have a local library listed. And if we click on that, we'll see our CRM data cleanse listed as a library node that we can now use within our graph. And we can drag another instance of this library node onto our canvas to use within our existing model. So, with just a few configuration steps, we created a completely reusable asset to perform our CRM data cleanse that we can now use in future models or even share amongst a team of users within our organization to promote a more team-oriented approach to maintaining and processing data. And if we want to make changes to this library node and have those changes propagate out to all the various instances of the library node, it's a very simple and straightforward process. If we click on the Show Library button here, it'll enter into what's known as library node, where we can actually edit the details of that particular library node. So in this case, let's say that we want to add a second output to this composite that represent the actual null accounts that we discovered within our filter node. So I can create a secondary output within this composite, and we'll call this null accounts. And I wired it up to the output of our filter node that represent those null accounts. And now if we go back to our canvas, we'll see that both instances of the CRM data cleanse library node have been updated with a secondary output that represent those null accounts. So not only do we have a completely reusable asset to handle our CRM data cleanse activity for future models, we also now have a way to centrally maintain any updates we want to make to that node and push it out to all of the users that are sharing it as well. And the reality is that we're kind of dealing with a complex computer science concept here of composition, inheritance, and augmentation. And this library node functionality within the LavaStorm Analytics engine basically puts the power of object-oriented programming into the hands of business analysts without requiring them to be computer programmers or even to write a single line of code. As we continue to iterate through our model, implementing business rules on the fly, driven by the very data we're actually analyzing, eventually we'll come to a point where we want to do something with the results. These results might be a set of discrepancies or anomalies that we need to pass on to another group for investigation, or perhaps we've completed a series of acquisition and transformation steps that resulted in a nice, clean, federated data set that we now want to output to a visualization tool such as Tableau or ClickView. Regardless of the scenario, we have a set of data that we need to publish to something or to somewhere. So just like on the acquisition side of the product, we can also publish to a large variety of different data sources and systems. So we can publish the data as delimited. We can publish it as Excel, as XML, even as HTML. And we also have native integrations with visualization products such as ClickView or Tableau and even Spotfire. We can send the results as email. And then just like on the acquisition side with the database query node, we can also write back to database tables directly. So again, Oracle, Teradata, SQL Server, DB2, all natively supported on the publishing side as well. So let's output some of our results to an Excel spreadsheet as our boss requested. So if I drag and drop the output Excel node up onto the canvas, and in this case I'm going to take the matches from our cross-reference, and I'm also going to take all of the customers that have been refined that are not in billing and input that into the output Excel node as well. And then if we open the output Excel node, and we'll tell it simply that we're going to write this to my desktop, and we'll call this analysis.xlsx. And then actually, if we go to the input, we can name what these inputs will be. And the reason we want to do that is that these inputs translate to the worksheets that actually get created within the workbook. So here we'll call this full matches, and then the second output we'll call not in billing. And now if we run this node, it's going to create that Excel workbook on our desktop with the resulting data sets. And if we go to the desktop, we can verify this by seeing there's an analysis spreadsheet that was created. If we open it up, we'll see two worksheets here, the full matches as well as the not in billing. So just like that, we were able to take our results and our refined results and actually output those into an Excel workbook. The output Excel node also supports templates, so you can even do dashboarding within Excel if you're used to that sort of model within your organization. So up until this point, we've acquired various data sources, and we've discovered some data anomalies from the data directly, and we implemented several business rules to deal with those data anomalies, and generally configured this entire model without writing any sort of code. And within the LavaStorm Analytics engine, there's a surplus of nodes that function in this same sort of straightforward configuration mode or approach. However, there are other nodes within the product that provide the capability to do freeform scripting or even coding for our more technical users that prefer that approach. And the filter node is one node that provides this sort of flexibility. The filter name itself is a bit of a misnomer because its script parameter actually provides an open environment for doing a variety of tasks such as complex data transformations, mathematical operations, or even field manipulations via a scripting language that we call BrainScript. BrainScript is a language similar to SQL or even to VBScript that you'll find in Excel macros, but with a bit more functionality optimized towards data manipulation as well as data transformation. And in reality, BrainScript is just a component of a broader 5GL or fifth generation language development environment that the product empowers. Another way to think of it is this. BrainScript is used to govern the behavior of specific nodes. However, the broader connection and interaction of these individual nodes throughout an end-to-end model, some with BrainScript, some without, provide a very powerful development environment unlike anything in the market today. And that development environment is what enables the wide spectrum of users, from business analysts to data scientists, to be self-sufficient and highly effective within the product. And we can access the full set of operators available within BrainScript from any script parameter window within the nodes. So in here, we can see the full range of functionality available. We see everything from string operators to numeric operators to regular expressions and even lists, which are similar to arrays. Additionally, BrainScript supports autocomplete and tooltips within its operation. So if we type in replace here, we're going to get an autocomplete window as well as a tooltip for that particular function. So this autocomplete functionality and built-in intelligence makes coding within BrainScript very easy and straightforward for even our non-technical users. There's extensive help and documentation built directly into the product that covers core product concepts, BrainScript, in every single node that ships with the product. There are also several training and reference videos on our website covering a wide range of product concepts and use cases. And additionally, all of our users have access to the LavaStorm community forums, which is basically a highly collaborative forums for users to interact and discuss LavaStorm technology, to do everything from inquire about new product features to even crowdsourcing challenging data problems to the broader user groups. In addition to that, our engineers, consultants, and sales engineers all moderate the forum, so questions posted are often answered within a 24-hour period. In the 5.0 release, a new concept called tour guides was introduced, and tour guides basically provide step-by-step instructions to guide users through complex node configuration, further simplifying the use for our users. If we open up the Excel file node as an example here, we'll see step-by-step instructions walking the users through those various parameters that they need to fill out in order to execute and leverage the node. And just like with library nodes, users can create their own tour guides, which provide for better enablement and reuse across an entire team, but also establishes a degree of control and governance on how a shared library node should be used across those various users. So this concludes our blank slate demonstration, and over the past 20 to 30 minutes, I've basically walked you through how to construct a model from the ground up on top of the data live. So again, we worked through this problem set the way we logically thought through the problem set, looking at the data at each step along the way, inspecting, iterating, uncovering business rules, and then ultimately publishing a set of results to an Excel spreadsheet in this case. And we did it in the fraction of the time that it might take with traditional tools like SQL or Excel or even an Access database.